Student, you are welcome to the second episode. In the first episode, we discussed lastly about speed with the direction. What is the term? Speed with the direction. Suppose a body moving along a straight line with a uniform speed. Then here it is moving along straight line. That shows direction. That shows direction and also speed. That term we used to represent with a velocity. What is actually velocity? Speed with a direction, or a body moving along a particular direction. Then we can consider its rate of displacement as velocity. So velocity is the, what is actually velocity? Velocity equal to displacement by time. Velocity equal to displacement by time. How we get the unit of this one? We know unit of velocity. Unit of velocity is displacement unit is meter, time, second. So meter per second. This we can write in this way also, meter per second. Unit of velocity is meter per second. Now, if the body is moving along straight line with a non-uniform speed, if it is moving with a non-uniform speed, then we consider average velocity. What we consider there? Average velocity. So average velocity equal to total displacement by time. Here, if this average velocity, we can also express it. Suppose if it is moving with a non-uniform velocity, and if the velocity is increasing gradually at the same rate, then its initial velocity we can represent with u. Initial velocity is represented with a u, and final velocity with a v. Final velocity is with a v. Then average velocity, that is v average is equal to, that means u plus v by 2. This shows the average velocity. V average equal to u plus v by 2. Here u is the initial velocity and v is the final velocity. From this we get average velocity. Now with this average velocity and other terms, here one activity is given for you. Suppose when you heard thunder, when you heard thunder, you can get a lightning before it. That means after lightning, sometimes only you will get after lightning, sometimes only you will get a thunder. What is the reason for this? You know, sound travels nearly 360 meter per second. What is the speed of sound? 360 meter per second, nearly. But what is the speed of light? It is 3 into 10 raised to 8 meter per second. So the speed of light is very high. These two happening, that means lightning and thunder occurred at the same time, but due to the high speed of light, the light reaches to us at first. But the sound travels at a speed of 360. Suppose we observed the lightning, then the thunder occurred after suppose 5 seconds. then the distance of that we can calculate by using 360 into 5. That shows the distance from our lightning and thunder happens. This way we can calculate it. Now with these states, that means speed, average speed, velocity and average velocity, some questions given to you. You want to answer it. First question is distinguish between speed and velocity. What do you want? Right? Distinguish between speed and velocity. What is the difference? Speed, distance traveled in unit time. Here distance in unit time. Here displacement in unit time. Speed only magnitude. Speed is only with the magnitude. Here both magnitude and direction. Velocity is with both magnitude and direction. Then this speed, its unit is meter per second. Here also unit in meter per second. Speed, that means speed is a scalar. Velocity is a vector. And some other difference, speed only 0 or positive, but velocity can be positive or negative. That means these are the difference between speed and velocity. Once again, what is speed? It is the distance traveled in unit time. Here displacement in unit time. Then it's speed with only magnitude. Here magnitude and direction. Here both of them with the same unit, and speed is a scalar. Here it is a vector. This is the answer for the first question given to you. The next question is, under what conditions is the magnitude of average velocity of an object is equal to the average speed? That means when does average speed and average velocity becomes equal? When does average speed becomes equal to what is average velocity? That is the question to you. Here average speed and average velocity both are equal. When does this become equals? When the body is traveling along a straight line. When a body is traveling along a straight line, then average speed and average velocity becomes equals. When does body moves along straight line, then average speed and average velocity becomes equals. And third question given to you. What does the path of an object look like when it is in uniform motion? Suppose a body in uniform motion, then how is its path? How is its path? In which path it travels? It travels along straight line. That means for uniform motion, body travels along straight line. And fourth one, during an experiment, a signal from spaceship reached the ground station in 5 minutes. What is the distance of spaceship from the ground station? The signal travels at a speed of light, that is 3 into 10 raised to 8 meter per second. That means from a spaceship, signal reached t is equal to 5 seconds. Signal reached to us and the time taken to it is 5 seconds. Now the speed of it is 3 into 10 raised to 8 meter per second. Now what we want find? We want find that the spaceship is how much distance away from us? We know that is distance d is equal to that velocity or speed into time. That is equal to v, that is 3 into 10 raised to 8 into here the time taken given as 5 minutes, not a second, 5 minutes. Now this minute we can change into second, that is 5 into 60 second. So the distance d is equal to v into t, that is equal to 3 into 10 raised to 8 into time 5 into 60. When we multiply this, what we get? 3 into 5 50, or 5 times 6 equal, or 5 times 6 30. That 3 and 3 9, and 2 0 into 10 raised to 8 meter away, that one. That is 900 into 10 raised to 8 meter away, that you can convert into kilometer by dividing with 1000. So this is the distance of spaceship from us. Now, another question given to you is the odometer of a car reads 2000 kilometer. Odometer of a car reads 2000 kilometer at the start of a trip, and 2400 kilometer at the end of the trip. If it took 8 hours, calculate average speed of the car in kilometer per hour and meter per second. What is the question given? In a car, its odometer at first shows 2000 kilometer. After 8 hours, it shows 2400 kilometer. You want to find average speed in kilometer per hour and also in meter per second. First of all, we can find out that is distance traveled. Distance traveled by the car is equal to 2400 minus 2000, that is equal to 400 kilometer, and the time taken for that, is equal to, that is 8 hours. How much it is? 8 hours. Now we know what is average speed. Average speed equal to total distance, that is 400. Total distance in kilometer by total time, that is 8. Total distance 4400 divided by total time taken 8. That is equal to 50 kilometer per hour. This is the average speed in kilometer per hour. Average speed in kilometer per hour. How much is 50 kilometer per hour? Now we want to find it in meter per second also. How we change kilometer per hour into meter per kilometer per hour into meter per second. See here, average speed is equal to 50 kilometer per hour. This 50 kilometer we are going to convert it into meter by multiplying with 1000. And this hour we change to second. We know 1 hour is 60 minutes and 1 minute is equal to 60 seconds. Now this, how this 1000 is coming? 50 kilometer means 50 into 1000 meter. And 1 hour is 60 minutes into 60 seconds. that when we simplify, we can cancel on 0, again on 0. Now with 2 we can cancel. Here we'll get 25, here 3, and again with 6 and 10 we get 3 and 5. This will get 25 to 5 on 25 divided by 9. Now when you divide this on 25 with 9, that is on 2, 5 with 9. In total on times, that is 9. Balance 3 and 5. That is in 35. This 9 is approximately 4 times, or we can take as that is 3 times, that is 27. Now balance from 35, 27 will be deducted, 8 will get 8 and 0 in 80, 90. 9 how many times? 9 times 9 is 81, so 8. This will get us 13.8 meter per second. Now we got average speed in kilometer per hour and meter per second. This is the average speed of car in kilometer and also in meter per second. Now one more problem is given there, that is Usha sinks a 90 meter long pool. 90 meter long pool. She covers 180 meter in 1 minute. That is 180 meter in 1 minute. Then by swimming from one end to the other and back along the same straight path, find the average speed and the average velocity of Usha. That means a 90 meter long pool this way. One pool is there. What pool? From here to here, 90 meter long. From this to this side, 90 meter long. And she swims from here to and again back to the same path. That means on this side 90 and return 90. That is 180 meter in 1 minute. So what we want to find is the average speed and average velocity. We know average speed is equal to total distance 180 by total time 1 minute means 60. That is equal to 180 by 60. Total distance traveled 180 and the time taken. And the time taken for it is 60 seconds. That means 1 minute is 60 seconds. Now cancel 6. This. Now in 18, 6 how many times? 3 times. So 3 meter per second is the average speed of Usha. And now we want to find out average velocity also. Now what we want to find out? We want to find out average velocity. See, she starts from here, from the one end of the pool, and she swims to the other edge, that means 90 meter, and to the same path she returns back again 90 meter. But you see, she is at this point itself now. That means her starting and finishing point is same. So here the displacement is equal to 0. Displacement of Usha is 0 meter, and time we know 1 minute. So average velocity is equal to displacement 0 by time 60. That is equal to 0 meter per second. That is average speed, average velocity. Average velocity of Usha is 0 meter per second. Why? Because there is no displacement. Why there is no displacement? She starts from one end and goes to the other end and return back to the same point, same path to the same point. So displacement is 0. So average velocity here is also 0. Okay, these are the two problems given to you in text. Now we are going to another term, that is a rate of change of velocity. What is a rate of change of velocity? That means how velocity varies with the time. When a body moves along a straight line with a uniform velocity, when we take its change in velocity, see, when a body or an object moves along a straight line with a uniform velocity, that means its velocity is not increasing or velocity is not decreasing, its velocity always remains the same. Then the change in velocity, how much will be it? Change in velocity in that case is how much? Change in velocity is 0. If that one is not moving with a uniform velocity, if it is not moving with a uniform velocity, then it's a change in velocity, then it's a change in velocity. If it is not moving with a uniform velocity, then its change in velocity is not 0. Not 0 in that case. That means if the body is not moving with a uniform velocity, then its change in velocity is not 0. So the change in velocity, how the velocity changes, to find it, we introduce a new terms. We introducing a new terms, and it is called acceleration. Usually we used to represent a letter A, that is small letter A. So acceleration is actually a rate of change of velocity. That means acceleration is equal to rate of change of velocity, means change in velocity by the time taken to that change. So acceleration is the rate of change of velocity, or it is the change of velocity in 1 second. Hence this acceleration can be taken as A is equal to, suppose a body moving with its first velocity u, and then its velocity becomes v. At first the velocity of a body is u. After time t, its velocity becomes v. Now the change in velocity is v minus u. Once again, consider a body or a car or a bus or train. At first its velocity is u. After some time, that means after some time here means t. It may be 5 minutes or 5 seconds or 10 minutes or 20 seconds, etc. Its velocity now become v. Now the change in velocity is v minus u, and the time taken for it is t. So acceleration is equal to change in velocity by time. So A is equal to v minus u by t. Acceleration is how much? A is equal to v minus u. Suppose if this acceleration When does this acceleration becomes positive? If the acceleration is in the same direction as velocity, that means velocity and acceleration, these two are in same direction, which are velocity and acceleration are in the same direction. For example, a stone falling from the roof of a building. Here the acceleration and velocity both are in the same direction. Then it is positive. Now, acceleration can be negative also. Which is negative. That is velocity and acceleration. That means acceleration is opposite to velocity. Which acceleration is opposite to velocity. When does the acceleration is opposite to velocity, then this acceleration is negative. Suppose when we throw a stone in upward, when we throw a stone vertically upward, then its acceleration is downward, that is acceleration due to gravity, and velocity is upward. When we throw a stone in the upward direction, that means its velocity is in the upward, so it is going up, but that velocity is gradually decreasing, hence the acceleration is in the downward direction, that is opposite. So acceleration can be positive and negative. When does if the velocity and acceleration are in the same direction, then they are in positive. And if they are in opposite, then the acceleration is negative. Now, one activity is given to you. You want to find its answer. When acceleration, that is in your everyday life, you come across a range of motion in which acceleration is in the direction of motion. Suppose a car is speeding, then the acceleration is in the direction of motion. Acceleration is against the direction of motion. Suppose when a car is moving, we apply brake. Then its acceleration is that means acceleration is against the direction of motion. When does the acceleration is in the direction of motion means when a moving car, when we speed up, motion and acceleration both are in the same direction. Suppose when we apply brake, both are in the opposite direction. Acceleration and direction of motion are in the opposite direction. And one more, acceleration is uniform, and when does it become non-uniform? That means acceleration is uniform for a freely falling body. When does acceleration, example for acceleration is uniform, acceleration is uniform for a freely falling body, acceleration is uniform. When does non-uniform, for example, suppose a car moving towards a crowd, then what is its speed sometimes increase, sometimes decrease, then the acceleration becomes non-uniform. Suppose a car, when we apply brake, then we speed up in this way, its acceleration becomes non-uniform. Now, one question is given to you. That means that question here is starting from a stationary position, Rahul pedals his bicycle to attain a speed of 6 meters per second, 6 meters per second in 30 seconds. Then he applied brakes such that velocity of the bicycle comes to down 4 meters per second, 4 meters per second in next 5 seconds. Next 5 seconds. The question is given. At first, Rahul pedaled his bicycle for 30 seconds. Then, when he pedaled his cycle for 30 seconds, its speed become 6 meters per second. And after he applies brake, when he applies brake for 5 seconds, That means 5 seconds, its speed become 4 meter per second. Now we want to find out acceleration in both cases. Now after first step, we can take case 1. Case 1. Its initial velocity u equal to 0. Why? Initial velocity u equal to 0. Why? Now the initial velocity u becomes 0 because it starts from rest. It starts from rest, so u equal to 0. And final velocity v equal to 6 meter per second. Now the time taken for that to change t is equal to 30 seconds. 30 seconds. Now we want to find out acceleration. A is equal to b minus u by t. That means acceleration is the change in velocity by time. Acceleration is the change in velocity by time. That is equal to 6 minus 0 by 30. That is equal to 6 by 30. Now in 6, in 30 here 6, 5 times, here 1 time. This on, here 5. That is equal to 1 by 5. That is equal to 0.2 meter per second square. Unit of acceleration is meter per second square. Unit of acceleration is meter per second square. Now case 2 we can consider. In the first case u is equal to 0 and v is equal to 6 meter and time taken 30 seconds. Now a is equal to v minus u by t, that is equal to 6 minus 0 by 30, that will we get on simplifying 0.2 meter per second square. Now we are going to find out second case. See, in the second case, case 2. In the case 2, when he starts to apply brake, its velocity is 6 meter per second. When he starts to apply brake, its velocity is 6 meter per second. So u is equal to initial velocity, u is equal to 6 meter per second. And after applying brakes for 5 seconds, its speed becomes, that is final velocity becomes 4 meter per second, and the time taken t is equal to 5 seconds. Time taken for it is 5 seconds. We know acceleration is the change in velocity by time. Change in velocity is v minus u by t. That is equal to 4 minus 6 by t 5. When we subtract 6 from 4, we get minus 2 by 5. That is equal to minus of u1 divided 2 with 5. Can we take 5 from 2 directly? No, it is not possible. We giving a decimal point then 20. In 20, how many times? 4 times. That is 20. So its answer is minus 0.4 meter per second square. At first average acceleration is 0.2 meter per second square, and second its acceleration is 0.4 meter per second square. Now this acceleration is but it is positive, and this one is it positive or negative? Now the acceleration, second acceleration is negative. Now we got both acceleration as positive and negative. Now some questions given to you to answer in your text. When will you say a body is in uniform acceleration? Question is this: when you will say a body in uniform acceleration? When we will say if the increase in velocity equals at equal interval of time. If the increase in velocity is equal in equal interval of time, then its acceleration is uniform. For example, for a freely falling body, in the case of a body falling downward, each second velocity increases 9.8 meter. In the first second, next second also it is 9.8 meter per second. So the increase in velocity in this case equal, so it is in uniform acceleration. And second, non-uniform acceleration. Second one is non-uniform acceleration. When does it become non-uniform acceleration? Suppose a car moving through a curved road. Suppose a car moving along a curved road, then the acceleration is not uniform. Suppose when the car takes curve, its acceleration changes. So its velocity changes, hence acceleration is not uniform. That is an example of non-uniform acceleration. Now another question. A bus decreases its speed from 80 km per hour, 80 km per hour to 60 km per hour in 5 seconds. What are the values given here? A bus decreases its speed 80 km to 60 km within 5 seconds. We want to find its acceleration. See, we know acceleration is the change in velocity by time. Hence, here, see, at first its velocity, that is u is equal to 80 km per hour. And final velocity v is equal to 60 km per hour. And the time t is equal to 5 seconds. Now, we know acceleration is equal to change in velocity, that is v minus u, that is 60 minus 80 by 5, time taken. Change in velocity by time, that is 60 minus 80 by 5, that is equal to minus 20 kilometer per hour by 5 seconds. Here this is kilometer per hour and here in second. So we can convert both in kilometer per hour. We are going to change into meter per second. That is minus 20. This kilometer we can convert into meter by multiplying with 1000. And this hour we can change into second by 1 hour is 60 minutes and 1 minute is 60 seconds into this 5. Okay. Now we can simplify this. That is on 0, 0. Here also on 0, 0. Now, more simplification we can learn. See, in this 25 is 4 times. And this minus 4 into 10, that is equal to 40. That is minus 40 divided by 36. Minus 40, 4 into 0, 40 divided by 36. How much it will come? Minus 40 into 36. When we divide without a negative sign, we can divide at first. Then we can give the negative sign. That is equal to minus 40 by 36. 1, 36, remaining 4. Now, here no more digit, so give decimal, 40 again, on, 36, again 4, that is on. In this way it will repeat. That means acceleration is minus 1.11 meter per second square. Because this negative acceleration we used to represent, it is called retardation. This negative acceleration is called retardation. Dear children, now we can also represent this motion graphically. What is actually graph? It is the picture of the given data. You used to see in cricket match, that means run rate represented in bar graph. Here, motion we can represent with a straight graph, that means a line graph we can use. Suppose a body moving, then it's a distance time graph we can draw. That means a distance time graph. In distance time graph means distance along the y axis and time along the x axis. If the motion is uniform, then the graph we get as a straight line. If the motion is uniform, then the graph is a straight line. Suppose OA represent OB. Let OB represent, as in the figure, OB represents distance time graph of a body moving with a uniform speed. Then we want to find out its speed from this. Let A and B are 2 points. Now we draw line parallel to y-axis. Here the time t1, and from here this time t2, and a line from A, this AC parallel to x-axis. This is the x-axis, and this one is a y-axis. Now from this, the speed we get, v is equal to, we know speed is the distance by time. So here v is equal to distance, that is bc. That means let it be this distance s1 and this distance s2. So speed v is equal to s2 minus s1 by t2 minus t1. So speed from this graph, that means the distance time graph, v is equal to s2 minus s1 divided by t2 minus t1. We know speed is equal to distance by time. Here we got a graph. That graph is a straight line. That graph is a straight line for uniform motion. Suppose if the body is uniformly accelerated body, the distance time graph is like this way. It is not a straight line. For a uniformly accelerated or accelerated motion, the graph may not a straight line. That is like this way we get a graph. Okay. Today we discussed about what is average velocity, how rate of change of velocity, acceleration, and we discussed about different problems which to calculate acceleration, velocity, average velocity, etc. Now graphical representation to represent a motion, of a body, and its distance time graph, that means distance along the y and time along the x-axis. If it is uniformly accelerated, then the graph is a straight line, and the speed from this v is equal to s2 minus s1 by t2 minus t1. If it is not a uniform or accelerated motion, if it is not a uniform speed, that means if it is in an accelerated motion, the graph may not be a straight line, or graph is like this way we get it. Okay, with this we can wind up today's class.